Hello everyone. Today we will discuss about thermal expansion. As the name itself indicates, thermal expansion is the expansion in an object due to heat supplied. It is of three types. The first is linear expansion. This is the expansion in length due to heat supplied. So if we consider a length L, which on getting heat is expanded by delta L length. So this is original length and this is the change in length. So we can say that the change in length is proportional to the original length, and this change in length is also proportional to the change in temperature. If we remove the proportionality sign, if we combine this first, this will be L delta T, and if we remove the proportionality sign, we will get alpha L delta T, where L is the original length and this is delta T is the rise in temperature, and alpha is coefficient of linear expansion. Now coefficient of linear expansion can be written as, if we mark this as 1, from 1 we can write alpha is equal to delta L upon L delta T, right? To define coefficient of linear expansion, we can use this method. If L is equal to 1, delta T is equal to 1, then alpha is equal to delta L. So we can write down coefficient of linear expansion is the change in length per unit length per unit degree rise in temperature. Right? So this is the definition of alpha, that is coefficient of linear expansion. Second is areal expansion. This is also called as superficial expansion. So the other name is superficial expansion, right? Now obviously, as the name itself indicates, this is the change in area when heat is supplied to it. So you can say expansion in area due to heat supplied. So if we draw a sheet, whose length and breadth, original length and breadth are, this is L, this is B, and on expanding L increases by delta L and B increases by delta B. So the final sheet becomes this, right? Because this is delta B B. Now this change in area is proportional to original area. This is also proportional to change in temperature. So on combining these, we can write it like this. On removing the proportionality sign, we can write down like this. So this is actually original area and this is rise in temperature, where beta is the coefficient of aerial or superficial expansion, right? So beta can be defined in the same manner as we had defined alpha. So definition of beta. So beta can be written as delta A upon A into delta T, right? So the same manner we can write down, if A is equal to 1, delta T is equal to 1. So beta can be written equal to delta A, right? So we can define it. Beta can be defined as change in area per unit area for unit degree rise in temperature, right? If I want to write the unit of alpha or beta, what will be the unit? Length unit cancelled, so this will be temperature inverse. So you can say unit of alpha is Kelvin inverse or Celsius inverse. Similarly here, unit of beta is Kelvin inverse or Celsius inverse. Why? Because area units are cancelled, then this will be 1 upon temperature. Now we can take the third expansion, that is volume expansion or the cubical expansion. Right? So what is volume expansion? Obviously it's a change in volume due to heat. Expansion in volume due to heat. Right? So if we consider the body having LBH, length, breadth and height, then obviously there will be change in length, change in breadth and change in height. So that's why there will be volume change overall. So we can write down here, change in volume is proportional to the original volume. It is proportional to the change in temperature, and if we combine these two, we get this is proportional to V delta T, and if we remove the proportionality sign, we will get delta V is equal to gamma V delta T, where gamma is equal to coefficient of volume expansion. And this V is original volume and this is rise in temperature. Now we can derive a relation between alpha, beta and gamma. For that, first we will derive a relation between alpha and beta, then alpha and gamma, and then we will combine. So we will first write down between alpha and beta. For that, if we write the original area, you can consider the same diagram as L into B, initial area. Final area will be L plus delta L into B plus delta B. We can multiply it. This will be LB plus L delta B plus B delta L plus delta L delta B. This is final area. We can mark these equations as 1 and 2. This one is 1. This one is 2. And this one as 3. And we can, I have not written the definition of gamma. Gamma you have to define yourself. Right? So here, this one as equation 4. This one as 5. We will neglect delta L into delta B as delta L is very small, delta B is very small. So their product will also be small. So this we will neglect. Right? So we can find delta A by del AF minus AI. So this can be written as LB plus L delta B plus B delta L plus L minus LB. This is the initial and this is the final. So if we solve it, we will get L delta B plus B delta L. This is delta A. Right? If we divide the whole equation by LB, divide this fifth equation by LB, what will I get? Delta A upon LB is equal to L delta B upon LB plus B delta L upon LB. Yeah, this L will be cancelled from here, this B will be cancelled from here, and this can be written as A. So what can this be written? Therefore, next step will be delta A upon A is equal to delta B upon B plus delta L upon L. If I divide the whole equation by delta t. Divide 6 by delta t. What will I get? Delta A upon A delta t is equal to delta B upon B delta t plus delta L upon L delta t. What is this? This is beta from equation 2, or you can say this one, and this is breadth is also length now. There will be linear expansion, so this change in length upon original length into change in temperature, this is alpha, this is also alpha. So therefore beta is equal to 2 alpha. This is an important relation. So this is our A part done. This I can mark as 7. Now I can take the second part where I have to find the relation between alpha and gamma. For that I need to take a cube. I am taking a cube of side L. Therefore delta L is the change in length or side of cube, right? So I can write the initial and the final volumes. Therefore I can write initial volume is L cube and final volume will be L plus delta L whole cube, because this change in length will be every side, this side, right, this side and this side as well as. So this will be a bigger cube, right? So what will be the change in volume? Change in volume will be final volume minus initial volume. So what will it be? This will be L plus delta L whole cube minus L cube. Let's solve it by A plus B whole cube formula. Delta V is equal to, this is A cube plus B cube plus 3A square B plus 3A B square, right? And this final volume, this initial volume is as it is. Yeah. So we know that delta L is very small. So we can neglect the cube of delta L. So this will be neglected. And this will also be neglected, because we know that if we have 0.1, then 0.1 into 0.1 is 0.01 and 0.1 into 0.1 into 0.1 is 0.001. So these are smaller, so this is also neglected. So if we solve it, what will we get? Delta V is equal to L cube plus 3L square delta L. This we have neglected, this we have neglected, minus L cube as it is. So this will be cancelled. So our delta V is actually 3L square delta L. If we divide this equation, this is 8. Yeah. Divide 8 by L cube. What will we get? We'll get delta V upon L cube is equal to 3L square upon L cube delta L. So what will be cancelled? This square will be cancelled. Yes. And this will be volume. So this will be delta V upon V, because this part is what? This is volume. So this is equal to 3 delta L upon L. If I divide this equation by delta T, what will I get? delta V upon V delta T on left side, and this is 3 delta L upon L delta T on right side. So what is this? This is change in volume upon original volume into delta T. So gamma is what? Change in volume upon original volume into delta T. So this I can write gamma is equal to 3 change in length upon original length into delta T. This is alpha. So I have got another equation. This is equation 10. So from 7 and 10, alpha is to beta is to gamma is equal to 1 is to 2 is to 3. That means alpha upon beta is 1 upon 2. Beta upon gamma is 2 upon 3. Alpha upon gamma is 1 upon 3. So these are the relations between alpha, beta and gamma. I hope you understood it. That's all for now. Have a nice day.